Good morning, dear student. In previous lecture, we already discussed some linear pi systems such as ethylene and allyl radical. In today's lecture, we are very much interested in the next linear pi system, that is 1,3-butadiene. So this 1,3-butadiene is exist in cis as well as in trans form, but for our convenient, we consider it as a linear system or linear pi system. So 1,3-butadiene. So if we consider, we can easily find out the HOMO and LUMO for this 1,3-butadiene. So the procedure is very simple. So you should represent the p orbital interactions and find out the highest occupied molecular orbital and lowest unoccupied molecular orbital. So if you consider, there is a total 4 electrons. So 2 pi bond is there. So one pi bond made up of by 2 electrons, and a second pi bond is made up of by 2 electrons. So total 4 electron is there, and total 4 carbon is there. So total 4 carbon is there means total 4 wave function is there. Total 4 p orbitals are involved in bonding, and which results into the formation of bonding as well as uh, non-bonding, bonding as well as anti-bonding interactions. So let us discuss. So 1,3-butadiene, total 4 wave function is there because total 4 carbon is there. And the first one, we are known that the psi1, in this case all the 4 p orbitals, all the 4 p orbitals. So this is your psi1. All the 4 p orbitals are in same phase means the double bond get delocalized over all 4 carbons. So you should keep in mind, whenever the p orbital in same phase, the electron or the pi bond get delocalized, or the electron get delocalized over all the 4 carbon atoms, and which results into the formation of bonding molecular orbitals. So 2 electron is goes here. Psi1, it contains 2 electrons. So whenever the last electron is present in that wave function, it is your HOMO, and the unoccupied molecular orbital, or the orbital does not have any electron, it is your LUMO, that is lowest unoccupied molecular orbital. Psi2, if you consider the psi2, then the psi2 must have a one node. Psi2 must have a one node, and we know that this is your symmetric molecule is there. And if you consider how we can represent only one node, so out of these 4 p orbitals, 2 in one plane and 2 in another plane. So this is the case. So this is your bonding interactions. This is your first p orbital, this is second. So both having both in same phase, so this is your bonding interaction. But if you consider this p orbital second and third, they have opposite phase, they in opposite phase, and therefore there should be a node, that is your anti-bonding interactions. And again, this is your bonding interactions. So this is your psi2, and it involve 2 electrons. So total 4 electrons in psi1 and psi2. The third one, that is psi3, so no electron is there, that is your lowest unoccupied molecular orbit. So this is your HOMO, so you should keep in mind. So psi2 is your HOMO for 1,3-butadiene. Many times the question is asked, what is your HOMO and what is your LUMO, and where the electron is transferred. So we already discussed the carbonyl ligands. So what is the HOMO of this carbonyl and what is the LUMO of this carbonyl? So you should keep in mind why we discuss or why we study this p orbital interactions for this kind of ligands, that is linear pi system and cyclic pi system. So at least you should know what is HOMO and what is LUMO for this ligand. And if you consider psi 3 means there is a two nodes. So two node is there. So this is your four p orbitals. So how can represent two nodes should be there? So and this is your node. So what it indicate? These two p orbital in different phase. And if you consider there is another node, then so there is a one bonding interaction and two anti-bonding interactions. So in this case all are bonding interactions, and this is bonding, this is bonding, this is bonding, three bonding interaction. In this case only two bonding interaction, this is one and this is second. So this is your bonding interactions, bonding interactions, this is bonding interaction. So there is only one bonding interactions, only one bonding interaction. There is a three node should be there, and it is empty, it is empty. And again there is a psi 4 means total there is a three nodes should be there. So we can represent like this. So three nodes means all carbons, all p orbitals of each carbon in different phase. So this is if you consider this is your negative, this is negative, this is negative is there, and this is negative is there. So no bonding interactions, all are anti-bonding interactions. So if you consider there is a three bonding interaction, there is a two bonding interaction, there is only one bonding interactions, and this is your no bonding interactions. And this psi 4 is also your empty, and this is your LUMO, that is lowest unoccupied molecular orbit. This is your LUMO. If you consider this is your LUMO, and this LUMO, if you consider this is your symmetric LUMO, and this is your anti-symmetric LUMO is there. So this LUMO is your symmetric, and this is your anti-symmetric. This LUMO is symmetric, and this is your anti-symmetric LUMO. So this is the pictorial representations for this 1,3-butadiene. That is the psi 2 is your HOMO, and psi 3 is your LUMO, and psi 4 is also your LUMO. So you should keep in mind the p orbital interactions for this 1,3-butadiene. So one should know that how many carbon is present uh, is is equal to the number of wave functions. If there is a 4 carbon, then there is a 4 wave functions. And the nodes, so we know that node, the wave function -1, so it indicates the number of nodes and which p orbitals are involved in bonding and which does not involve in bonding. So this is regarding to the 1,3-butadiene. Let us discuss the one more example, that is your cyclic C6H8. It is not cyclic, it is a linear pi system. So because we already we discuss only the linear system, in the next lecture we discuss the cyclic system, that is C6H8. C6H8. So total 6 carbon is there, means total 6 wave function is there, C6H8. So if you consider this is carbon number 1, 2, 3, 4, 5 and 6, and if you consider this is your CS2, this is your CS2. So this is linear system, CS2. Okay, this is your CS3, this is your CS3. Let us consider. So yeah, we are maintaining the valencies. So how we maintaining the valencies? Let us discuss once again. So this is your carbon, 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 carbon. Total 1, 2, 3, 4, 5, 6 carbon is there. So we write here the conjugation. That is because we consider the pi system. So in this case, if you consider the double bond, alternating double bond, single bond, double bond is there. So we are very much familiar with this conjugation. So and then maintain the valency of the carbon, that is CS2, and then this hydrogen is there, again the hydrogen is there, again the hydrogen is there, hydrogen is there, and this is your CH2. So if you consider, total 6 carbon is there and total 8 hydrogen is there. So this is your linear pi systems, and total 3 pi bond is there. So total 1 pi bond contribute 2 electrons, so total 3 pi bonds, so it contains total 6 electrons. So 6 electrons should be there. In this case, 6 electrons should be there, and we know that. So total carbon is 6, so total wave function is 6. So let's discuss the p orbital interactions for this C6H8, and let us find out the HOMO and LUMO for this C6H8. So the first one is very simple, that is your bonding interactions. So 1, 2, 3, 4, 5 and 6, 5 and 6. So all p orbitals of carbon atoms in same phase that involve in bonding interactions, and therefore this is your bonding interaction. So 2 electron goes here, this is your psi1, so there is a no node should be there. Then psi2 should be there. So again it is symmetric molecule, psi2 should be there. So psi2 means there should be only one node is there. So one node we can representing like this. So 3 p orbital in same phase, 3 p orbital in same phase, and 3 p orbital in different phase. So this is your site. Again this is also your bonding interaction. So how this is your bonding interaction, because this is your bonding, this is your bonding, again this is your bonding, this is your bonding, and this is your anti-bonding interaction. So total 1, 2, 3, 4 are bonding and 1 is anti-bonding. So total 3 bonding interactions. So it is also your bonding interactions. 2 electron goes here, then your psi3 means there should be a 2 node is there. Psi3 means 2 nodes should be there. So how we can show a 2 node should be there? 2 nodes should be there. So we can write here 1 node and there should be 1 node. Okay, so this is the node, means this will be like this. There is a no node, there is a node, there is a no node, and this is also the no node. So if you consider this is your bonding, this is your bonding, this is your bonding. So 3 bonding and 2 anti-bonding interactions. So 3 minus 2, so we get 1 bonding interaction, and this is also your bonding interaction. So 2 electron goes here. So should keep in mind. So total bonding interactions minus anti-bonding interactions, which results into the bonding interaction. So 1, 2, 3 are bonding interactions, minus 2 are anti-bonding interactions, and therefore we get 2 electron is there. This is your psi3. Then the next one is your psi4 is there. Psi4, psi4 means there is a total 3 nodes should be there, and 3 nodes should be there. What it indicates? So how one can represent the 3 nodes in this system? That is, if you consider this is your 1 node, okay, then if you consider this is your 1 node, then this is your second node should be there, this is your also 1 node. So total 6 carbon is there, but 2 carbons, 2 p orbitals of carbon atoms does not involve in this bond formation, because we how we can draw a three node should be there. So this is one node, then we can write this is another node should be there. So we can write this as like this. Let's discuss it. So to represent, so we can write here to represent three nodes. So we can represent three nodes for this psi4. So how will you represent three nodes? So this is 1, 2, 3 and 4. So this is the representation for psi4. So this is your one node, this is your second node, and this is your third node. Third node should be there, because only this representation gives you three nodes. What it indicates, if you see this, we get three nodes. It indicate only 4p orbitals are involved. Only 4p orbitals are involved in these interactions. Only 4p orbitals are involved, and 2p orbital does not involve. So 2p orbital does not involve in this case. So if you consider this node is considered as 1p orbital, and this node is also considered as a 1p orbital. So 1, 2, 3, 4, this is 5 and this is 6. Okay, this is if you consider 2p orbital does not involve in interactions, only 4p orbital is involved, and only then we get three nodal representation for psi4. So you should keep in mind, many times the confusion is there how we can represent the number of nodes, because the total carbon is 6, but we represent only here the 4p orbital, because 2p orbitals not involved in bond formation, so they're acting as a node. So this is your carbon, this is your carbon, they acting as a node, so they are not involved in bonding, therefore psi4. So if you consider here, all these are antibonding interactions. It should be there. There is no bonding interaction. Then psi5 should be there. If you consider this is your psi4, then psi5 should be, psi5 is there should be a 4 node should be there. There should be a 4 node. So how can we can write 4 node? Let's discuss. Total 4 nodes should be there. So 4 node we can easily show like this. This is one node, second, third and fourth. So there should be chances of one bonding interactions, and remaining are antibonding interactions. So this is one, no, this is your antibonding interactions, this is your antibonding interactions, then this is your, there should be no node should be there. So this is your bonding interactions, this is your antibonding interactions, and this is also your antibonding interactions. So only we get so in psi4 only 4p orbitals are involved in only 4p orbitals of carbon atoms, 4 carbon atoms are involved in bonding. In this case all are involved, but if you consider this is your antibonding interactions, antibonding, this is also your antibonding, this is your bonding interaction, this is also your antibonding, and this is also your antibonding. So 1, 2, 3, 4, 4 antibonding minus 1 bonding, so 3 antibonding interactions should be there. 3 antibonding interactions should be there. So to represent nodal representation, so you should understand, many times we write all 6p orbital, many times we write only 4p orbitals. So you should understand and draw the pictorial representation to show the nodal representation, to show the nodes in that p orbital interactions. So total there is a 4 node should be there, and the last one, that is your psi6 wave function is there. What it indicates, there is total 5 nodes. So it is very simple. So all 6 p orbitals, so 5 nodes should be there. So this is your one node, this is your second, then this is your third, this is your fourth, and this is your fifth. So total fifth should be there. 5 nodes should be there. So this is your all are antibonding interactions, so psi3 is your homo and psi4 is your lumo for your C6H8. The heading is for 1,3-butadiene, but you should remember it is not 1,3-butadiene, it is C6H8, but it is linear. It is linear one. Linear pi system should be there. Linear pi system should be there. So C6H8, it is your linear pi system. In next lecture, we will discuss the cyclic pi system, the p orbital interaction for cyclic pi system. Thank you.